All right, so for today's lesson, it's a review from last year. It's dealing with linear and quadratic systems. The solution of a linear quadratic consists of the intersection of the graph of a line, linear, and a parabola, which is your quadratic. The solution of a linear quadratic may consist of either 2 points, 1 point, or no points. We're only going to be graphing systems whose solutions have 2 points. So the idea is when you solve a linear and a quadratic, what you need to do is draw the graphs of both equations on the same coordinate plane. Feel free to label, well, you really should label both the graphs, but it should be obvious as to which one is the quadratic and which one's the linear, but go ahead and label them anyway if you'd like. Make sure that when you graph the quadratic, you need to create a table of values that's centered on the vertex. The equation for the x-coordinate of this vertex, which is the axis of symmetry, is found by x equals negative b over 2a. To plug, then to find the y value, you plug in that x-coordinate. Don't forget that quadratics are in the form of y equals ax squared plus bx plus c. So you can see where the a and the b are coming from, and the y-coordinate is when you plug in the x and you have all the numbers, you can find that out. Once you graph both your line and your parabola, you're going to find the common solutions by reading the points of intersection of the two graphs. You might want to check your answer on the calculator, and that you do by second trace intersect, and then you have to enter 3 times. But don't forget you have to do this thing twice because there are 2 points of intersection. Your solution should always be written as ordered pairs, right? And that's always your x and your y. So here's where we're going to go. Find the solution set for these two particular functions. If I worry about the line first, I'm going to graph that where my y-intercept is 3 and my slope is -1. So I'll go down 1 over 1 or up 1 over 1. And there happens to be my line. Again, to label it is a good idea. For the parabola, don't forget it's y equals ax squared plus bx plus c. My axis of symmetry, because I need to show this work algebraically, is negative b over twice a. Well, my b is what's attached to my x-coordinate, and that's going to be -2. My a is what's attached to my x squared coordinate, and that's going to be 1. So then what ends up happening is x equals 2 over 2, or x equals 1. When I now go into look for my y value for my vertex, I'm going to take my original equation for my parabola, and I'm going to dump in my x value. That was a 1. So when I do the math here, I get 1 minus 2 plus 1, and that ends up being 0. So in terms of my vertex, it's going to be 1, 0. And what I'm going to do here is I'm going to create a table of values centered on that particular point. So I'm going to, whoopsie, let's get this back up. Oh boy, I'm going to pause for one. Okay, so then I'm going to take a table of values and I'm going to center it around the vertex. And then I'm going to go to my graphing calculator and figure out what are the points that I want. And if you remember from last year, you really want to be symmetrical on either side of the vertex. So if 1 is your vertex for the x-coordinate, then you want to find the y values for 2 and 3, and you want to find the y values for 0 and -1. So the idea is on the graphing calculator, I'm going to go to my seat and do this. So on the graphing calculator, you're going to type in the equation for the parabola. So I've got this over here. So I'm going to go into my y equals, and I'm going to type in the equation for the parabola first. So I have my parabola is x squared minus 2x plus 1. And if I take a look at my graph, there it is. And it looks as if my vertex really is at 1, 0, but what I'm going to do is I'm going to go to my table of values and really locate that vertex. Here's 1, 0. As I kind of go up a little bit, I can see where -1, 0, 1, 2, and 3, all of those 5 values really are symmetrical around that vertex. Just going to go up one more so I see the y values really match. But for the table of values, you're going to put in 1, 4, 0, 1. We already have the vertex. And then we're going to put in 2, 1, and 3, 4. So I'm going to go back to the board. And I'm going to fill this stuff in. So we know we're going to be at negative 1 was 4. And then 0 was 1. We already had the vertex. And then 2, 1, 3, 4. So when we graph this now on our grid, and I'll use the table of values, so negative 1, comma 4, 0, 1, 1, 0, 2, 1, 3, 4. When I graph this, I do see that I have 2 points of intersection. Now, it's not so clear really on mine what those ordered pairs are. Maybe it's more clear on yours, and that's okay if it's not super clear where those points are. You have the calculator to figure that out. And here's what you're going to do next. You are going to do that second trace intersect, or you look at your table of values. It's completely up to you. But I'm going to go to the calculator. I'm going to go into y equals. I don't have the line in there yet, so I need to do that. Negative x plus 3. Oopsie, I didn't mean to clear that one up. Let me try this again. So I've got x squared minus 2x plus 1. In y2, I've got negative x plus 3. I'm going to graph this. Looks exactly like what we have on our own grid. And then I'm going to go second trace, which is calculate, choice 5, which is intersect, and then I'm going to hit enter 3 times. Enter, enter, enter. And the first ordered pair that pops up is negative 1, 4. So that's really what this is supposed to be, but my graph isn't so good. I've got to find out what this one's going to be next. So I'm going to do that whole thing over again. I'm going to go second trace, and I'm going to go down to intersect. But before I hit enter 3 times, I have to move this cursor away from this first ordered pair. So I'm going to move my cursor away. It doesn't have to be exactly on top of the second point. I'm just going to put it anywhere that's on the other side of the first point. And now you can hit enter 3 times. And the second ordered pair, maybe you knew this already, was 2, 1. So your solutions then are negative 1, 4 and 2, 1. And you're going to write those things as ordered pairs. So that's what I'm going to do here. So I've got my solution. Let me see if I can bring this down a little bit. So the solutions. And then the answers become, again, negative 1, 4 and 2, 1. Okay, so this is what this first problem is going to look like. We'll do the same thing for the second problem. I'm not going to be showing you the calculator. I trust that you can do that on your own, but I will show you the work. So let's go into the second problem. And the second one here is, again, go ahead and graph the line first. This line, I need to get it into y equals. So I'm going to add x to both sides. It's going to be x minus 2. So I'm going to begin at negative 2, up 1 over 1, up 1 over 1. Again, it looks like I'm beginning at negative 3 because I'm not oriented very well. So make sure that your graph is good. For the parabola, I know that the vertex is going to start out with the axis of symmetry. Your x equals negative b over 2a. I've got a negative 6 that I plug in for my b, a 1 that I plug in for my a. Negative 6 is positive 6 divided by 2. So my x coordinate is 3. I take that x coordinate and I plug it into the parabola. So y equals x squared minus 6x plus 4. Again, the x coordinate is 3. When you do the math, you're going to get y equals 9 minus 18 plus 4. And 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So your vertex that you're going to center this graph around is going to be centered around 3, negative 5. Feel free to use your calculator and pull out the other ordered pairs. The other ordered pairs that you're going to be pulling out around this would be 1, negative 1, 2, negative 4, 3, negative 5, you knew, 4, negative 4, and 5, negative 1. So this is what you're going to plot for your parabola. So we've got 1, negative 1, 2, negative 4, 3, negative 5, 4, negative 4, 5, negative 1. There's your parabola. We do, in fact, have 2 points of intersection. And if you need to, whoopsie, I'm supposed to highlight that. If you would like to, feel free to go to your calculator, unless your graph is really good, and pull out those ordered pairs. It's by second trace intersect. And it turns out the solutions for these guys are going to be 1, -1, and then the other one's going to be 6, 4. Okay, so there you go. Again, you're just going to be graphing the two graphs on one line, on one grid, and then figuring out your common points of intersections. All right, so that's it. Good luck on the homework.